It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with a test.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your rating.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
So welcome to Unacademy, the largest online e-learning platform, and welcome to Unacademy Semester Exams. And the crash course is Network Analysis and Transmission Lines. Revision of Unit 3 or Chapter 3 we say. So let me tell you about myself. I am sravan Kumar, having 7+ years of teaching experience and mentored more than 5K students for GATE and engineering services, and also cracked GATE. Now Unacademy, let's crack it. Let's crack GATE and ESE with India's largest learning platform, Unacademy, and get subscription to Unacademy. So we have Unacademy Learning app. Type Unacademy Learning app in Google Play Store and click on this install. That's it. You get the installation and you get these benefits. Daily live classes, structured courses, live test series, quizzes, unlimited access. Then in Iconic subscription, you have personal coach, study tracker, mains question and answer practice, all benefits of Plus. In Plus subscription, you find daily live classes, structured courses, live test and quizzes, unlimited access. Then you can learn from the top educators. As you can see, there are many top educators of Unacademy. And in GATE and for GATE and ESE, you have batches and year-long batches with almost all the branches, all the different specializations. And in Iconic subscription, you have all the benefits of Plus along with some dedicated personal coach, personal test analysis, study planner, and preparatory study material benefits. So for the Plus subscription, you can go with the 24-month subscription. You also have 1, 3, 6, 12, 18 months. You can use my code YSK10 to get the maximum discount and unlock the free courses, and you can get subscription to Plus plan. Or you can also rather get subscription to Iconic for 24 months. You can use my code YSK10 to get maximum discount, and for 24 months you can subscribe. It's a suggestion to get subscription to 24 months in Iconic plan. And Evolve for GATE 2021 is 1-year course for the students opting for 2022, and 2023 Ascend is the two years crash course for the 2 years course for the second year students who are planning to prepare for GATE 2022 and 2023s. So this is a part of revision of Unit 3, Network Analysis and Transmission Lines. So now let's start this Unit 3. So in the previous two chapters we have done in unit 1, I'll just roughly tell you as a revision. We have done what is topology and magnetic circuits, and in unit 2 you can see we have done resonance and also time response. Now in this we would see in unit 3 we have two port network and network functions. So probably this is the two port network complete concept. So let's try to do that. Two port network. You can see this two port network. A port is a pair of terminals. Let's say this is a black box. Let's consider one black box which has some circuit in it with RLC elements. And if you have a pair of terminals, or what is a port is? Port is a pair of terminals through which a signal is fed or taken. You can fed or taken. We'll call this as V1 I1. This is a network. Now this is called as a one port network, a single port network. What is a one port network? A network that has one pair of terminals. In other words, what is that? Two terminals is called a one port network. The above example that you can see, a generator, a motor. Now let us consider a two port network. A network which has two pair of terminals or four terminals is called a two port network. Now let us consider this. Let's say this is one network which is consisting of some elements, and you have pair of terminals at this port, and you also have pair of terminals here. Now here if you see, this is, let us call this as V1 I1, and let's call this as V2 I2, and this is a network. And wherever you give supply is called as an input port, or you can also call it as port 1, and this you call it as output port where you connect a load, or you can also call it as a port 2, port 1 and port 2. So we will name these terminals as 1 1 dash and 2 2 dash. 1 1 dash represents input port here, and 2 2 dash represents output port. 1 1 dash represents input port and 2 2 dash represents output port. Now let us look at multi-port network. Let's look at multi-port network. A network that has multiple pair of terminals. A network with multiple pair of terminals is a multi-port network. Like you can see, you have a network here which has multiple ports. Here you have ports. You can see here the same way here. This is a multi-port network. This is a network. You have V1, I1, V2, I2, anything can be. V3, I3 or V4, I4. Likewise, this is an example of a multi-port. This is a multi-port network. A multi-port network. Now let us see all these networks we have seen, and now let us consider a two-port network. As I told you, in a two-port network you have two terminals at the input port and two terminals at the output port. Two terminals at the input port and two terminals at the output port. This is a network. I1, V1, I2, V2. Now of this you can say four variables: I1, I2, V1, V2. V1, I1 are the voltage and current at input port, and V2, I2 are the voltage and current at output port. Now of these, if you select two, it is NCR is equal to n factorial by n minus r factorial into r factorial. You can also look at it that way, or you can also say you have different parameters. One is Z parameters, Y parameters, H parameters, ABCD parameters, or you also have inverse H or G parameters and inverse ABCD or ABCD parameters. These are the different parameters that you have. Because this is a revision, I'm just trying to tell you very quickly. Z parameters are also called as open circuit parameters. Because it is Z, you can also call it as impedance parameters. Similarly, Y parameters are also called as short circuit parameters or admittance parameters, and H parameters are also called as hybrid parameters, and ABCD parameters are called as transmission parameters. Right? So these are the other names that you can give for these types of parameters. Types of parameters. Now let's write all the parametric equations. Let's write all these first four. Then you can write the rest of them easily once you know them. So let's write Z parameters and Y parameters in this particular page. What are Z parametric equations? V1 is equal to Z11 I1 plus Z12 I2. V2 is equal to Z21 I1 plus Z22 I2. Similarly, I1 is equal to Y11 V1 plus Y12 V2. I2 is equal to Y21 V1 plus Y22 V2. Here you can say The dependent parameters are V1 and V2 and independent parameters are I1 and I2. Similarly, in Y parameters, dependent parameters are I1 and I2. Independent parameters are V1 and V2. So from this, we can write when I2 you make it 0, that is open circuit port 2. Current 0 is open circuit. You get Z11 is equal to V1 by I1 and Z21 is equal to V2 by I1. Similarly, when I1 is equal to 0, open circuit port 1, you get Z12 is equal to V1 by I2 and Z22 is equal to V2 by I2. Likewise, for Y parameters, when you make V2 is equal to 0, that is short circuit port 2, you get Y11 is equal to I1 by V1, Y21 is equal to I2 by V1. Similarly, when V1 is equal to 0, that is short circuit port 1, Y12 is equal to I1 by V2, Y22 is equal to I2 by V2. Just look at this. This is the thing. Now, what do you call this? Well, let's see. Yes. Now, V1 by I1 or Z11 is called as driving point input impedance. Next, Z21 is V2 by I1 transfer impedance, forward transfer impedance. We'll write this in the next slide, so that would be better. Right, so let's write that. So Z11 is equal to V1 by I1, Z21 is equal to V2 by I1, Z12 is equal to V1 by I2, Z22 is equal to V2 by I2. We'll call this Z11 as driving point input impedance. This one as forward transfer impedance. This as reverse transfer impedance. You'll know better these things when you are dealing with network functions. This is driving point output impedance. And we get these two values when I2 is 0. And we get these two values when I1 is equal to 0. So, what is I2 is equal to 0 indicates open circuit port 2 and I1 is equal to 0 indicates open circuit port 1. Now similarly, if you write Y11 is equal to I1 by V1, Y21 is equal to I2 by V1. Similarly, Y12 is equal to I1 by V2 and Y22 is equal to I2 by V2. Raju, good evening, welcome. This is called as driving point input admittance. Now this is called as reverse transfer admittance. This is forward transfer admittance, and this is reverse transfer admittance, and this is driving point output admittance. So this is about z and y parameters. And when do you get this value I1 by V1? When V2 is 0. When V2 is 0. This is when V1 is 0. This is when V1 is 0. So these are the values that you get, Y11, Y12. Now let's look at A, B, C, D and H parameters. A, B, C, D parameters and hybrid parameters. A, B, C, D parameters are also known as transmission parameters. So what is this? V1 is equal to AV2 minus BI2. I1 is equal to CV2 minus DI2. V1 is equal to H11 I1 plus H12 V2. I2 is equal to H21 I1 plus H22 V2. So these are the ABCD parameters. What are the dependent variables in this? Dependent are V1 and I1. Independent are V2 and I2. Here dependent are V1 I2. Independent are V2 I1. Now let's write when I2 is equal to 0. When I2 is equal to 0, what is that you get? A is equal to V1 by V2 and C is equal to I1 by V2. Similarly, when V2 is equal to 0, you get B is equal to minus V1 by I2, D is equal to minus I1 by I2. And when V2 is equal to 0, H11 is equal to V1 by I1, H21 is equal to I2 by I1. And when I1 is equal to 0, H12 is equal to V1 by V2, H22 is equal to I2 by V2. So this we call it as voltage gain. This we call it as transfer admittance, and this we call it as transfer impedance, and this is current gain. Now let us look at the other things. Now H11 V1 by I1. This is input impedance. I2 by I1. This is current gain. V1 by V2. Reverse current gain. This is forward current gain. This is I2 by V2. Output admittance. So let's try to move this. Yeah, this is output admittance. So we can also write this as so these are A, B, C, D and H parameters. A, B, C, D parameters and H parameters. So V1 by V2 reverse voltage gain, I1 by V2 reverse transfer admittance, and V1 by I2 reverse transfer impedance, and I1 by I2 reverse current gain. Similarly, V1 by I1 input impedance, that is driving point input impedance. When V2 is short, or we can also call it as short circuit input impedance. This is forward current gain. This is reverse. This is V1 by V2 voltage gain. Sorry. Yeah. This is reverse voltage gain or open circuit voltage gain. We can also call it as. And this is I2 by V2 is driving point output admittance. So these are about A, B, C, D and H parameters. H parameters and A, B, C, D parameters. You can write inverse H or G parameters. That is I1 is equal to G11 V1 plus G12 I2. And V2 is equal to G21 V1 plus G22 I2. So you can write when I2 is equal to 0, G11 is equal to I1 by V1 and G21 is equal to V2 by V1. Similarly, when V1 is equal to 0, you can write G12 is equal to I1 by I2, G22 is equal to V2 by I2. So this is driving point input admittance. This is forward voltage gain when open circuit, and this is reverse current gain, and this is driving point output admittance, and the units are all mho. Sorry, this is ohms. You know units, mho, no units. So these are all the parametric equations. So let's write all the parametric equations once again. So parametric equations. Let's write all the parametric equations that we have seen. You can also write small a, b, c, d parameters. Maybe I did not write them. You can also write small a, b, c, d parameters. No, let's write z parameters first. V1 is equal to Z11 I1 plus Z12 I2. V2 is equal to Z21 I1 plus Z22 I2. Similarly, you can write admittance parameters as I1 is equal to Y11 V1 plus Y12 V2. I2 is equal to Y21 V1 plus Y22 V2. Similarly, you can write H parameters as V1 is equal to H11 I1 plus H12 V2 and I2 is equal to H21 I1 plus H22 V2. Similarly, you can write A, B, C, D parameters as B1 is equal to AV2 minus BI2, I1 is equal to CV2 minus DI2. You can also write all these parameters in matrix form. So if you take Z parameters, V1 is equal to Z11 I1 plus Z12 I2, V2 is equal to Z21 I1 plus Z22 I2. Now write this in the matrix form. V1 V2 is equal to Z11 Z12 Z21 Z22 into I1 I2. Similarly, you can write Y parameters. You can write Y parameters as I1 is equal to Y11 V1 plus Y12 V2 and I2 is equal to Y21 V1 plus Y22 V2. You can write in matrix form as I1 I2 is equal to y11 y12 y21 y22 v1 and v2. Similarly, if you consider a b c d parameters, consider a b c d parameters. v1 is equal to av2 minus bi2, I1 is equal to cv2 minus di2. So v1 I1 is equal to a b c d v2 minus I2. So these are a b c d parameters. चलो देखते हैं अभी h parameters. Now what are h parameters? Now v1 is equal to h11 I1 plus h12 v2. I2 is equal to h21 I1 plus h22 v2. You can write this as v1 I2 is equal to h11 h12 h21 h22 into I1 v2. So these are h parametric equations. So that is how you'll write these things in the matrix form. Now let's look at one problem to which we'll find the rest of the parameters. I'll tell you only one parameter, then we'll go ahead with the other questions, other topics. Then if time permits, we'll come back. So let's consider one question. Let's consider one question. So let me consider one question. I'm trying to take one question, one very good question. Yeah. So let's say this is the question. Find Z parameters of the given network, and the network is given like this. This is given as V1, I1 plus minus dependent source. This is 3 ohms, 2 ohms, 4 ohms, I2, 2, 2 dash, V2, 1, 1 dash. Now, what is that question that is asked for us? We are asked to find Z parameters. So, what are Z parameters? First write them. Z parameters. V1 is equal to Z11 I1 plus Z12 I2, and V2 is equal to Z21 I1 plus Z22 I2. Now once you know this, right, how do you get Z11, Z12, Z21, Z2? When you make I2 is equal to 0, you get Z11 is equal to V1 by I1 and Z21 is equal to V2 by I1. And when you make I1 is equal to 0, you get Z12 is V1 by I2, Z22 is equal to V2 by I2. So this is when I1 and I2 are made zeros. So that's how we have to solve this question. So first case is, this is case 1. When I2 is equal to 0. What is I2 is equal to 0? Open circuit port 2. When you want to open circuit this port 2, let's look at this circuit. So this is 3 ohms, 2 ohms, 4 ohms plus minus V1. Now when you make this I2 is equal to 0, so what happens to this dependent source? This is plus minus 0.5 I2. So this is a voltage source, right? So when this is a voltage source, 0.5 I2, when I2 is 0, 0.5 into 0 will give you 0. What does voltage 0 indicates? It will indicate a short circuit. So replace this total by a short circuit simply. Now this will be a circuit. Here I2 is 0 but voltage will exist. Because I2 is 0, voltage across this 2 ohm resistor is also 0. So therefore what is the voltage V2? V2 voltage is the voltage across 4 ohm resistor. That is 4 ohm resistor into current. This is the V2 voltage across. Now let's apply KVL to this. What will get KVL? V1 is equal to 3I1. This is I1 current. Plus 4 into I1. So V1 is equal to 7I1. And we know V1 by I1. What is V1 by I1? It is Z11 is 7 ohms. So you got one value. Similarly, you can write what is V2 is equal to. V2 is equal to 4 into I1. Actually, it should be 4 into I1 plus I2, but I2 is 0. So V2 is equal to 4 into I1. So V2 by I1. What is V2 by I1? Z21 is equal to 4 ohms. So we got two values, Z11 7 ohms, Z21 4 ohms. So this is when I2 is 0. This is when I2 is 0. Now let's consider the other case. Case 2. What is the other case? Case 2. When I1 is equal to 0. Let's consider the circuit. You give supply to the secondary side. So this is V2. This is I2. I1 V1 plus minus 0.5 I2, 3 ohm, 2 ohm, 4 ohms, but I1 is 0. So you can write V2 is equal to 2 into I2, second loop, plus 4 into I2, that is V2 is equal to 6 I2, V2 by I2 is equal to 6 ohms. What is this V2 by I2? Z22. Now let's write in the first loop. What is in the first loop? If you see, V1 is equal to, there is a voltage. So this is minus plus and this is plus minus. So it is 0.5 I2 plus 4 into I2. So this is V1 is equal to, V1 is equal to 4.5 I2. So V1 by I2 is equal to 4.5 ohms. What is V1 by I2? It is Z12. So finally you can say you get four values, Z11, Z12, Z21, Z22. What is Z11? Z11 is 7 ohms, Z21 is 4 ohms, Z12 is 4.5 ohms, Z22 is 6 ohms. So you can write this as V1 I1 matrix is equal to Z11, Z12, Z21, Z22 into V1 V2. V1 V2 is equal to I1 I2. Did I write the same in the when I am writing the matrices? Yes, correct. Now you can write this as V1 V2 in matrix form is equal to Z11 7, Z12 4.5, Z21 4, Z22 6 into I1 I2. Therefore, this is the final answer for the given question. Right. So this is how we will do this problem on a given question. Now let's look at the next concept. Interrelationship between parameters. Interrelationship between the parameters. Now whenever one parameter is given, you will have to find the interrelationship between them so that it is easy to find the rest of the parameters. And how do you do that? That is very important. So let us say z in terms of, now how many you need to find, that you have to understand. You need to find z in terms of y, z in terms of h, z in terms of abcd, z in terms of inverse abcd, z in terms of inverse h. Similarly, y parameters in terms of z, in terms of abcd, in terms of h. Similarly, abcd parameters in terms of z, y and h. Likewise, you need to find all the combinations. Any of these can be asked in your exam. So in order to do that, first we'll do z parameters in terms of h parameters. Let us say this is the z parameters in terms of the h parameters, right? So first write z parameters as well as h parameters. v1 is equal to z11 i1 plus z12 i2. v2 is equal to z21 i1 plus z22 i2. So this is z parameters, right? H parametric equations. v1 is equal to h11 i1 plus h12 v2, and i2 is equal to h21 i1 plus h22 v2. Now z parameters in terms of h parameters, in the sense you need to convert h parametric equations in terms of z parametric equations. Now if you see here this equation, v1 is in terms of function of i1 and i2, and v2 is also the function of i1 and i2. Now if you observe this, v1 here is a function of i1 and v2. Now what you have to do, you have to get i1 and i2, right? So you already have i1, you need to replace this v2. So find v2 from the second equation. So what you will do, find v2 from the second equation. So you can write v2 is equal to, from the second equation, i2 minus h21 i1 by h22. Now substitute this, whatever you got from this second equation, this you got it this from this equation, substitute back in this first equation. So you'll get v1 is equal to h11 i1 plus h12 v2. Now when you have done this, when you have just tried to find this v2 from the second equation, there will be a relation that is established between these two if you observe. And if you can see, you can directly write from that v2 both are same. Here i1 coefficient, what is i1 coefficient? Here i1 coefficient is z21. Then z21 is equal to, what is i1 coefficient? Minus h21 by h22 minus h21 by h22. Now similarly, if you write i2 coefficient z22, so z22 is equal to 1 by h22. This is the i2 coefficient here, 1 by h22. So one combination is finished. Then what we were doing, we were actually trying to substitute v2 back in this v1. So let's try to write v2 back in v1. So what was v2? v2 is equal to i2 by h22 minus h21 by h22 i1. Substitute in this, what do you get? v1 is equal to h11 i1 plus h12 v2 is i2 by h22 minus h21 by h22 i1. So just rearrange them. v1 is equal to h11 i1 plus h12 by h22 i2 minus H21 H12 by H22 I1. Now take common I1. If you take common I1, this is H11 H22 minus H21 H12 by H22 plus H12 by H22 I2. Now compare this equation with V1 is equal to Z11 I1 plus Z12 I2. Now can I write it as Z11 is equal to H11 H22 minus H21 H12 by H22. Now you can also write, just compare this Z12 and I2. So Z12 is equal to H12 by H22. Therefore, finally you can write Z parameters in terms of H parameters is Z11, Z12. Z11 is H11 H22 minus H12 H21 by H22, and Z12 is H12 by H22. Similarly, Z21 is minus H21 by H22. You can see this minus H21 by H22, and Z22 is 1 by H22. So this is Z parameters in terms of H parameters. Z parameters in terms of H parameters. Whenever you know H parameters, in order to find Z parameters directly, you can use these expressions. Similarly, we'll do other. Let's say A, B, C, D parameters in terms of Y. Let's do one more so that you'll have more clarity. A, B, C, D parameters in terms of Y. Let us say A, B, C, D parameters in terms of Y. Now let's look at that. Write A, B, C, D parameters first. V1 is equal to AV2 minus BI2. I1 is equal to CV2 minus DI2. And I1 is equal to Y11 V1 plus Y12 V2. And I2 is equal to Y21 V1 plus Y22 V2. Now compare these two equations. Compare these two equations. Now because you have I1 here, you also have I1 here, you can compare these two equations. This I1 is a function of V2 I2. Here I1 is a function of V1 V2. You want to write ABCD in terms of Y. That means you need to modify Y equations. So just try to write this Y equations. Take off this Y equations, and you need in V2 and I2. You need I2. You don't need V1. So find V1 from this. When you try to find V1 from this second equation, that equation will be almost equal to this first equation. Now let's do that. Find V1 from this equation. So that will be V1 is equal to, if you write I2 by Y21 minus Y22 by Y21 V2. Now if you compare these two equations, you can compare this equation. Let's call this as 1, 2, 3, 4 and 5. Now compare 5 and 1. You can compare 5 and 1. See V1 in terms of V2 I2, V1 in terms of V2 I2. So can I write A, which is the coefficient of V2. Here A is the coefficient. What is the coefficient of V2? Minus Y22 by Y21. What is B coefficient? B coefficient, I2 coefficient is minus B. So B is equal to minus 1 by Y21. So this is the value of A and this is the value of B. Now why did we find this V1? In order to change this equation 3. So let's try to change equation 3. So consider 3. What is 3? I1 is equal to Y11 V1 plus Y12 V2. We need to substitute V1 in this in order to modify this to I1 in terms of V2 and I2. So what is V1? V1 is 1 by y21 I2 minus this equation minus y22 by y21 y22 by y21 v2 y22 by y21 v2. So substitute this here back. So I1 is equal to y11 into 1 by y21 I2 minus y22 by y21 v2 plus y12 v2. Let's just do this. So we get I1 is equal to y11 by y21 I2 minus y22 by y21 y11 v2 plus y12 v2. So simplify this. I1 is equal to y11 by y21 I2 minus, take common v2 or plus v2 if you just take common. It is y12 minus y22 by y21. What do you get here? Now let's look at this. So I1 is equal to y11 y21 I2 plus y12 y21 minus y21 y22 y11, yeah, y22 y11 by y21 into v2. Now compare this with ABCD. I1 is equal to CV2 minus DI2. When you do that, C is equal to y12 y21 minus y22 y11 by y2, and D is equal to minus y11 by y2. D is equal to minus, right? So these are the values that you get. So finally you can write ABCD values. A is equal to, already you got, minus y22 by y21, and B is equal to 1 by minus 1 by y21. So this is how you will write ABCD parameters in terms of y parameters. Now let's see, this is the other concept, right? So what is this we have seen here? We have seen interrelationships. We have seen here interrelationships. Let's say you are doing some inverse parameters, then how should you do that? That will be very much easy. Now let us say you are doing some y parameters in terms of z parameters. Let us say this is the interrelationship that you are asked to find. Will be given in your exam. Derive the interrelationship between, or determine y parameters in terms of z, or z in terms of y, or ABCD in terms of z, or h in terms of y. This is how you will be given the question, and you should write it this way. Listen. So now y in terms of z. So just write y parameters first. I1 is equal to y11 v1 plus y12 v2, and I2 is equal to y21 v1 plus y22 v2. Similarly, z parameters. v1 is equal to z11 I1 plus z12 I2, and v2 is equal to z21 I1 plus z22 I2. Now let's try to write this in terms of matrix. I1 I2 is equal to y11 y12 y21 y22 in terms of v1 v2. So let's also try to write this in terms of v1 v2 is equal to matrix z11 z12 z21 z22 into I1 I2. Now if you observe these two, they are exactly inverse parameters, right? So you can find easily. So you should not change this y parameters, because we need to write y parameters in terms of z parameters. So you need to change this. Now how do you do this? Just consider those z parameters. v1 v2 is equal to z11 z12 z21 z22 into I1 I2. Now can I write this as I1 I2 is equal to Z11 Z12 Z21 Z22 inverse into V1 V2? Yes, you can. Right, because if you have A B is equal to C, you can write this A is equal to B inverse C. Likewise, so this is the other part, right? So, and you know already, if let's say A B C D is matrix A, then its A inverse is 1 by AD minus BC, D minus B minus CA. This is how you can easily write it down, right? Just remember this. So I can write it here as I1 I2 is equal to 1 by AD minus BC, Z11 Z22 minus Z12 Z21 D, Z22 minus B minus Z12 C minus C, Z21 minus and A Z11 into V1 V2. So we can further write this as I1 I2 is equal to, you can write this part as mod Z. So I'll write Z22 by mod Z minus Z12 by mod Z minus Z21 by mod Z and Z11 by Z11 by mod Z as a matrix and V1 V2. Now just compare this with, you have I1 is equal to Y11 V1 in matrix form, we'll just write it down. So I1 I2 is equal to I1 I2 is equal to Y11 Y12 Y21 Y22 into V1 V2. Similarly, you can write the obtained Z parameters, that I1 I2 is equal to Z22 by mod Z minus Z12 by mod Z, Z21 by mod Z, Z11 by mod Z of V1 V2. Just compare these two. You can write Y11 is equal to Z22 by mod Z. Look at this. And y12 is equal to minus z12 by mod z, and y21 is equal to z21 minus by mod z, and y22 is equal to z11 by mod z, or you can also write it as y11 is equal to z22 by mod z, that is z22 by Z11 Z22 minus Z12 Z21. Y12 is equal to minus Z12 by mod Z minus Z12 by Z11 Z22 minus Z12 Z21. Similarly, you can write Y21 is equal to minus Z21 by mod Z, that is minus Z21 by Z11 Z22 minus Z12 Z21. And y22 is equal to z11 by mod z, that is z11 by z11 z22 minus z12 z21. So this is how. Hi Arvind, welcome to Unacademy. This is how you will write interrelationships. We have seen interrelationships. Right, now let us see. Let us briefly see what are interconnections first. Interconnections. So if there are two two-port networks, they can be connected in either series or parallel or cascade. These are the three types of connections. These are the types of connections. So you can say series connection. What is that is, just consider two port networks like this. This is a two port network. Let's consider one more two port network here. This is another two port network. Now we just make a connection like this. This type of connection is called as series connection. Now let us. So this is two port network A. This is two port network B, and this has some V1, I1, I2, V2. So to this completely combination you will get V1, I1, and this is I1 double dash, V1 double dash. Let us call this as V1 dash, I1 dash, I2 dash, V2 dash, and this as I2 double dash, V2 double dash. This is the voltage V2 and total current I2. So this type of connection wherein this will enter this, come out, enter this again and come out. Similarly this will enter like this and it is coming out. Such type of connection is called as a series connection. Whenever you have such type of connections, you can see the current is same. The current that is flowing is same, but the voltage gets split. This V splits as V1 dash and V1 double dash. So here if you consider the Z parameters of this A network as ZA and Z parameters of this B network as ZB, the total Z parameters. So if you consider this as one two port network completely, the total Z parameters of this network is given by Z total is equal to ZA plus ZB. Now let us say these are Z11, Z12, Z21, Z22 of A and Z11, Z12, Z21, Z22 of B. So let us say this is A, and this is B, B and B. Now the total impedance or the Z parameters of the total network is sum of these two, sum of the impedances, Z parameters of the two networks, that is Z11A plus Z11B, Z12A plus Z12B, Z21A plus Z21B, Z22A plus Z22B. So this is how you will determine the series connection Z parameter, series connection. Now let us consider the other type of connection, that is parallel connection. That is a parallel connection. That is a parallel connection. Now let us consider two port networks like this. You have one two port network that is given like this. Let us call this as a two port network as A, and let us consider the other two port network as B, and which also has, because it is a two port network, we will have two input terminals as well as two output terminals. And similarly if you consider the other one also, it has two input terminals and two output terminals. Now if you just try to connect them such that they are in parallel. Now let us say this connection is called as parallel connection, if you can see. So this is a parallel connection. They are not connected here, you need to observe that they are not connected here, and this is a parallel connection. This is a parallel connection. Now, so this is two port network A and this is two port network B. Let us consider this as I1 and V1. 1, 1 dash, 2, 2 dash. Soumya, hi, welcome to Unacademy. Now let us consider this as V1 dash and I1 dash. This as I1 double dash, V1 double dash, I2 dash, V2 dash, and I2 double dash and V2 double dash. Now if you see, this voltage that is applied here is same as this, and this voltage is also same as this, but the current here is splitting into two parts. So you can write V1 is equal to V1 dash and is equal to V1 double dash. Similarly, V2 is equal to V2 dash and V2 double dash. V2 is equal to V2 dash is equal to V2 double dash. But this I2 and this is V2. You can write I1 is equal to I1 dash plus I1 double dash, and I2 is equal to I2 dash plus I2 double dash. Right? So this is how you will write it, parallel connection. So in this parallel connection, because the voltage applied is same and current is splitting, you can find the Y parameters of the total network. If you consider this as the total Y parameter, this as the total network, this has one total network. Combining these two, if you say that is a one network, you combine these two and you can see that. So Y parameters of total network is equal to Y parameters of network A plus Y parameters of network B. Let us say Y11, Y12, Y21, Y22 of network A. You have Y11, Y12, Y21, Y22 of network B. You can say this is A and this is B. Now the total Y parameters of this network is equal to sum of these two, Y11A plus Y11B, Y12A plus Y12B, Y21A plus Y21B, Y22A plus Y22B. So for a parallel connection, the Y parameters is equal to sum of Y parameters of the two different networks, sum of Y parameters of the two port networks. The other type of connection is third one, cascade connection, or we'll also call it as cascade configuration. This type of configuration is cascade. How this cascade configuration looks is, it will look something like this. It is a two port network. This is also a two port network. This is another two port network. Now let us consider the output of this is given as input to this, and the output of this is connected as input to this network. Now we call this network as two port network A and this is two port network B. Let us say you are giving some input to this and taking an output from this. So let us call this as V2 and this as I2 and this as I1 and V1, and let us call this as I1 dash V1 dash, this as I2 dash V2 dash, this as I1 double dash V1 double dash, I2 double dash V2 double dash. From this you can write the output of one two-port network is given as input to the other two-port network. From this you can write I2 dash is equal to I1 double dash minus, and V2 dash is equal to V1 double dash. Similarly here you can write V1 is equal to V1 dash, I1 is equal to I1 dash. Similarly you can write I2 is equal to I2 double dash, V2 is equal to V2 double dash. So whenever two two-port networks are connected in cascade, you can say that the total combination you can find the transmission parameters of the combination, like now if this is a complete two-port network, if you assume, so you can write the transmission parameters of the total network is equal to transmission parameters of network A plus transmission parameters of network B. Now let us call this as product. It is not summation, it is product of. This is product of, right? Now let us say this is A, B, C, D multiplied by A dash, B dash, C dash, D dash. Now T, total transmission parameters, is equal to A dash plus B C dash, B dash plus B D dash, C A dash plus D C dash, C B dash plus D D dash. So this is how you will determine the transmission or ABCD. Transmission is happening when you are connecting in cascade. So transmission parameters of cascade network, that is, it is product of ABCD parameters of two-port networks. So finally we have concluded that the types of interconnections or configurations, if you say, there are three types: 1, 2 and 3. First one is series configuration, next parallel configuration, next cascade configuration. So in series combination, you have the total Z parameters of two-port networks is the sum of two-port network A plus two-port network B. And in Y parameters, if you have Y is equal to same admittance parameters of parallel network is sum of the admittance parameters of the two-port networks. And in cascade connection, transmission parameters is the product. This is the only difference. This is the product of two-port networks. Product of the two-port networks. So this is type of interconnections. This is the type of interconnections. Next, now if you observe, you also have reciprocity interconnections. We'll solve one problem on it, or we'll go with symmetry and reciprocity condition. We have two types of conditions. One is symmetry and reciprocity condition. Symmetry condition and reciprocity condition. Now first we'll see what is a symmetry condition. Now let's see symmetry condition. For a network, if the driving point input impedance is equal to the driving point output impedance, it is said to be a symmetrical network. For a network, if the driving point input impedance is equal to the driving point output impedance, you can say that it is a symmetrical network. It is a symmetrical network. If the driving point input impedance is equal to the driving point output impedance, driving point input impedance is equal to the driving point output impedance, it is said to be a symmetrical network. That is, V1 by I1 is equal to V2 by I2. Driving point input impedance is equal to the driving point output impedance. Yeah, now if the driving point input impedance is equal to the driving point output impedance, then the network is said to be symmetrical network. If driving point input impedance is equal to driving point output impedance. So, and here a note is while finding, let's say you are finding driving point input impedance, you make the output port open. Now, if you are finding driving point output impedance, make the input port open circuit. So this is the condition. Now let's try to apply this symmetry condition for Z, Y, A, B, C, D and H parameters. So let's also represent this in terms of, let's also represent this in block diagram form, in circuit form. Let's say you have a network like this with input and output terminals. Let's also consider one more case, second case, and you have ports at the output and input terminals. And now let us see, this is V1, I1, I2, V2. This is case 1. Now when you make I2 is equal to 0, what is I2 is equal to 0? Open circuit port 2. When you make open circuit port 2, you need to find V1 by I1. What is that? Driving point input impedance. Now this is case 1 and this is a network. Now let us consider this is another case where I1, V1, I2, V2. That means you are giving this here V1 excitation. Here we are giving V2 excitation. And in this case, what you need to do is you need to make I1 is equal to 0. That is open circuit port 1 and find, and what do you need to find? V2 by I2. Now let's try to apply this. So let's try to apply for Z parameters. Let's take Z parameters. Z parameters, symmetry condition. Z parameters, symmetry condition. What is Z parameter symmetry condition? First we'll write V1 is equal to Z11 I1. We need to find that Z12 I2. And V2 is equal to Z21 I1 plus Z22 I2. What is case 1? Case 1 is when I2 is 0 find v1 by i1. Make i2 is equal to 0 in this equation, the above equation. In the first equation, if you make v1 is equal to z11 i1, in the second equation v2 is equal to z21 i1. What is the ratio that you need to find v1 i1? Can I get it from this equation? Yes, it is z11. v1 by i1 is equal to z11. Let's try to keep it aside. Now let's consider the second case. Case 2. What is case 2? When i1 is equal to 0, find v2 by i2. So let's try to do that. So we know v1 is equal to z11 i1 plus z12 i2, and v2 is equal to z21 i1 plus z22 i2. Now when i1 is 0, what is the equation? v1 is equal to z12 i2 and v2 is equal to z22 i2. Now what is the ratio that you need to find? You need i2 by v2. Can you get this from this equation? Yes. What is v2 by i2 is equal to, this is v2 by i2. So v2 by i2 is equal to z22. Therefore, symmetry condition for z parameters is, what is that? v1 by i1 must be equal to v2 by i2. What is v1 by i1? z1. What is v2 by i2? See, v1 by i1 is z11. v2 by i2 is z22. Therefore, this is the condition of symmetry for z parameters. Condition of symmetry for z parameters. Now let us consider y parameters. Now let us consider symmetry condition for y parameters. Now this would be a bit different. Now what are the two things that you need to consider? First write the parametric equations. I1 is equal to y11 v1 plus y12 v2. I2 is equal to y21 v1 plus y22 v2. Now let's try to take case 1. Now let us consider this case 1. v1 and I1, I2, v2. This is a network. So what I'll do is I2 is equal to 0. This is open. And we'll give some voltage to this V1. Now what is that you need to find? V1 is equal to, I2 is equal to 0. Find V1 by I1. So make I2 is equal to 0. When you make I2, you don't have first equation, you don't have I2. So in the second equation, if you make it, 0 is equal to y21 v1 plus y22 v2. Do you have v1 by i1 in this? No, you don't have it. Just write v1 from this. Or you need v1 by i1. So write v2. So v2 is equal to minus y21 by y22 into v1. This is v2 value, minus y21 by y22 into v1. Now you have this equation and you have this equation. From these two equations, substitute v2 value in the first equation so that you will get the total equation in terms of i1 and v1. You need to take the ratio of v1 and i1, right? So even if you observe this equation, you have i1, v1, v2. Even if you observe this equation that we have got after substituting i2 is equal to 0, we have only v2 and v1. Instead, what we can do is we can simplify this 1 and 2 equations. If I replace this v2 by this 2 equation, that means if I substitute this, the total equation will be in terms of i1 and v1. So let's write I1 is equal to y11 v1 plus y12 v2. What is v2 is equal to? We know minus y21 by y22 minus y21 by y22 into v1. Now substitute that here. So I1 is equal to y11 v1 plus y12 v2 minus y21 by y22 into v1. So from this, what you can do, you can take I1 and V1 common. If you take V1 common, what happens? Y11 Y22 minus Y12 Y21 by Y22. Now write V1 by I1 is equal to, this is what we need. That is Y22 by Y11 Y22 minus Y12 Y21. This is one equation that we got in first case. This is first case. Driving point input impedance. Now let's find the second case. This is the first case. Now let's take the case 2. Now let us take case 2. What is case 2? Consider the two-port network. And previously what we have done, let's see, I2 is equal to 0. Now take I1 is equal to 0. Take I1 is equal to 0. What is I1 is equal to 0 indicates? This is open circuit. You have V1. This is I2 and V2, and this is a network. Right? So we are giving supply to the second port. So you write I1 is equal to y11 v1 plus y12 v2. I2 is equal to y21 v1 plus y22 v2. Now I1 is equal to y11 v1 plus y12 v2, and I2 is equal to y21 v1 plus y22 v2. Now make I1 is equal to 0 in the first equation. You have y11 v1 plus y12 v2. You do not have I1 in the second equation. And second equation is y21 v1 plus y22 v2. When you make I1 is equal to 0, you need to find v2 by I2 ratio. But if you observe these are the two equations that we have, but in the second equation only we have I2 and also v2. So there is an extra v1. So try to find this v1 from the first equation, this equation. So what can I write there? This is I2, right? Now v1 is equal to minus y12 by y11 v2. If you just write this out down like this, you'll get it. This is v2 minus y12 v2 by y11. So what do you get? I2 is equal to plus y21 by, substitute this in this equation. So I2 is equal to y22 v2. I'm writing first this, then y21 into v1 minus y12 by y11 v2. So what can you write here? Just try to simplify this. I2 is equal to, take common v2. It is y22 y11 minus y12 y21 by y11 into v2. So write what is v2 by I2. You can write it as y11 by y22 y11 minus y12 y21. Just observe the same. Yeah. So you got v2 by I2 also. What did we get? We got v2 by I2 also. Then you can write symmetry condition for y parameters is, symmetry condition for y parameters is v1 by I1 is equal to v2 by I2. Right? What is v1 by I1? It is, what is v1 by I1? y22 by y11 y22 minus y12 y21 is equal to y11 by y11 y22 minus y12 y21. You can cancel this, so you'll get y11 is equal to y22 is the symmetry condition for, y parameters. Similarly, you can get the symmetry conditions for rest of the parameters also. You can get the symmetry conditions for rest of the parameters also. Let us take A, B, C, D parameters. Let us see. We'll also do symmetry condition. Let us say take A, B, C, D parameters. I'll do it without just drawing the diagrams. Symmetry condition. What is that symmetry condition? Let us see. For ABCD parameters, V1 is equal to AV2 minus BI2, I1 is equal to CV2 minus DI2. Case 1. Case 1. When you make I2 is equal to 0, find V1 by I1. Case 2. Make I1 is equal to 0 and find V2 by I2. Now when you make I2 is equal to 0, on this equation you will get V1 is equal to AV2, and in the second equation you will get I1 is equal to CV2. You need the ratio of V1 by I1. Divide these two equations. It is AV2 by CV2, that is A by C. V1 by I1 is A by C. Similarly, if you want to do this, just look at this. When you make I1 is equal to 0, you will get, you don't have I1 in the first equation, you have only I1 in the second equation. So 0 is equal to CV2 minus DI2, and you need to find the ratio of V2 by I2. By using this expression only, you can just do it. So CV2 is equal to DI2. So V2 by I2 is equal to D by C. Therefore, for symmetry ABCD, for symmetry of ABCD, V1 by I1 must be equal to V2 by I2. So what is V1 by I1? A by C is equal to D by C. A is equal to D. A is equal to D. A is equal to D is the symmetry condition for ABCD parameters. Now let us look at reciprocity condition. Let us look at reciprocity condition for parameters. Reciprocity condition. Now let me explain you what is reciprocity condition. Let us consider two cases like this. You have a network with output ports and input ports, and you have another network with input and output ports like this. So let us take this as case 1. Case 1, and this as case 2. This is a network. This is I1, V1, I2, V2, V1, I1, I2, V2. Now symmetry conditions was determined by open circuiting the ports. Here what you need to do is you need to short circuit the ports. Let's say in case 1, if you short circuit this port, second port, there is a flow of current I2 dash, which is I2 dash is equal to minus I2. That is the first point. And what is that other one? V2 is equal to 0. Here V2 becomes 0. When you make V2 is equal to 0 and short circuit this, you need to find the ratio of V1 by I2 dash, voltage at one port to the current in the other port. Now coming to the case 2. Case 2 is just short circuit port 1. Will have a current I1 dash. That means you are making V1 is equal to 0 and I1 dash is equal to minus I1. Then you need to find the ratio of this voltage V2. Here you give V1. So V2 by I1 dash, and this network is said to be reciprocal. For reciprocity, this ratio V2 by I1 dash must be equal to V1 by I2 dash. Again I'll write it. for a network to be reciprocal. Excitation to response or response to excitation. V2 by I1 dash must be equal to V1 by I2 dash. V2 by I1 dash is equal to V1 by I2 dash. They must be equal. Now, by using this, we need to determine the reciprocity condition for all the parameters. Now, let us take first reciprocity condition for Z parameters. What is the case 1? Case 1 is you need to take V2 is equal to 0 and write I2 dash is equal to minus I2 and find V1 by I2 dash. Right? So let's try to write for Z parameters. What are Z parametric equations? V1 is equal to Z11I1 plus Z12I2 and V2 is equal to Z21I1 plus Z22I2. So write this here. V2 is equal to 0. Substitute V2 is equal to 0 and I2 is equal to minus I2 dash. Alright. From this I2 is equal to, you can write it as minus I2 dash. So substitute that. In the first equation, if you substitute V1 is equal to Z11I1 plus Z12I2 is minus I2 dash. And in the second equation, V2 is made 0 and Z21I1 plus Z22 minus I2 dash. Now what is the ratio that you need to find? V1 by I2 dash. So I1 is extra here. If you observe, V1 by I2 dash. Here I2 dash you have it, but you have I1 extra. So find I1 from this equation and substitute back in this equation. That's it. So you'll find I1 is equal to, that is Z22 by Z21 I2 dash. Substitute back in this. So V1 is equal to Z11 I1. Need to substitute I1. What is I1? Z22 by Z21 I2 dash plus Z12 into minus I2 dash. We just take common I2 dash and find V1 by I2 dash is equal to Z11 Z22 minus Z12 Z21 by Z21. So this is V1 by I2 dash. This is V1 by I2 dash. Let's take case 2. What is case 2? When V1 is equal to 0 and I1 is equal to minus I1 dash, find V2 by I1 dash. So let's try to substitute in this. Write the equations. V1 is equal to Z11 I1 plus Z12 I2 and V2 is equal to Z21 I1 plus Z22 I2. So what do you get? V1 is equal to 0. Z11 I1 is equal to minus I1 dash plus Z12 I2 and V2 is equal to Z21 into minus I1 dash plus Z22 into I2. We need the ratio of V2 by, see here, V2 by I1 dash minus I1 dash or V2 by I1 dash, but there is an I2 extra. So find I2 from this equation and substitute back in this. That's it. So I'll substitute I2. If you find it, it is Z11 by Z12 I1 dash. Substitute in this equation of, so it is V2 is equal to Z21 minus I1 dash plus Z22 Z11 by Z12 I1 dash. So write this V2 by I1 dash. If you write it, just take I1 dash common. You will get Z11 Z22 minus Z21 Z12 by Z12. So this is V2 by I1 dash. This is V1 by I2 dash. Now this is V2 by I1 dash. Now for symmetry, now condition of symmetry for z parameters is v1 by i2 dash is equal to v2 by i1 dash. So v1 by z11 z22 z11 z22 minus z12 z21 by z21 is equal to v2 by i1 dash. z11 z22 minus z12 z21 by z12. You can cancel these two and write z12 is equal to z21. So this is the condition of reciprocity. Sorry, this is the condition of reciprocity. This is the condition of reciprocity for z parameters. Condition of reciprocity for z parameters. Similarly, you can find the condition of reciprocity for any parameter. Now let us take h parameters and see. Reciprocity condition for h parameters. Reciprocity condition for h parameters. Write h parametric equations. v1 is equal to h11 i1 plus h12 v2 and i1 is equal to h11 I2 is equal to h1 h21 i1 plus h22 v2. Right now, what is the case 1? Case 1 is when v2 is equal to 0 and i2 is equal to minus i2 dash. Find v1 by i2 dash. Find v1 by i2 dash. Now let's try to do that. Substitute v2 is equal to 0. So you'll get in the first equation v1 is equal to h11 i1 and in the second equation i2 is minus i2 dash is equal to h21 i1 plus h22 into v2. v2 is 0. So from this you can write v1 by i2 dash directly. So v1 by i2 dash, divide these two equations, this and this equation. If you just divide these equations, v1 by i2 dash is equal to minus h11 by h21. I1 will gets cancelled. So this is the first condition. Case 1. Now let's take v2 by i1 dash. Case 2, when here v2 is equal to 0, you need to consider v1 is equal to 0 and i1 is equal to minus i1 dash and find v2 by i1 dash. Find v2 by i1 dash. Right? H parametric equations. v1 is equal to h11 i1 plus h12 v2 and i2 is equal to h21 i1 plus h22 v2. So when v1 is 0, h11 i1 is minus i1 dash plus h12 v2. Similarly, i2 is i2 h21 minus i1 dash and h22 v2. We need to find v2 by i1 dash. From this equation itself you'll get it, right? So you can write h11 i1 dash is equal to h12 v2. So v2 by i1 dash is equal to h11 by h12. You can just write this reciprocity condition. Previously we have written symmetry. It's not symmetry, it's reciprocity condition for h parameters or hybrid parameters, you can say, is v1 by i2 dash is equal to v2 by i1 dash. v1 by i2 dash is equal to v2 by i1 dash. What is that? d1 by minus h11 by h21 minus h11 by h21 minus h11 by h21. Next v2 by i1 dash is h11 by h11 by h12. We can cancel these two, so you'll get h12 is equal to minus h21. This is the reciprocity condition for h parameters. So we have seen a reciprocity condition for two parameters, also symmetry condition for reciprocity condition for h parameters, and we have also seen a reciprocity condition for z parameters. Yeah, and also symmetry condition for abcd parameters, and symmetry condition for y and symmetry condition for z. So we have seen symmetry and reciprocity conditions, and reciprocity condition for z parameters is z12 is equal to z21, and for h parameters is h12 is equal to minus h21. Now this is all about two-port networks. So in two-port networks, I'll tell you what we have seen till now. We have discussed some of the things. I'll tell you what are those. In two-port networks, we have seen what are all the parameters, how they are named, how do we write them in the matrix form, and solved a problem on z parameters also. Then we discussed what is interrelationships. How do you find the relationship between, this is one question that is generally asked in your exam. Then we have seen what is interconnection also, interconnection between the two port networks. Then we have seen what is reciprocity and symmetry conditions also. So this is all about the two port networks. Now we need to see what is called as network functions. So now let us continue that third unit, network functions. I'll just briefly tell you what do we have in this. We have what is called as driving point function, and the other one is transfer function. So before that, let me tell you the transformed variable first. Transform variables. Let's say you have a resistor, and if you Laplace transform, you do not have any change in that. And let's say if you have an inductor L, when you transform it to S domain, you will get L into S. And when you have a capacitor, you can say it has transformed as 1 by Cs. Let me tell you what do you mean by that. Let us say you have an inductor, a capacitor, and a resistor with values, let's say 2 ohms, 5 farad, 3 henry, and this is v1, i1, i2 and v2. Now if you want to draw the transformed network, if you want to draw transformed network, then what you get is you just need to represent the same elements, just transform them. So you need to write this as v1 of s, and this as i1 of s, 3 l into s, 5s 1 by 5s 1 by cs, 2 is same, this is i2 of s, this is v2 of s. This becomes the transformed network. This becomes the transformed network. This becomes the transformed network of the given network. Right. Now let us discuss what is driving point function and transfer function. Driving point function. Driving point function and transfer function. It is ratio of variables at same port. Like you can write v1 by i1, v2 by i2, or i1 by v1, i2 by v2. That's how you can classify these driving point functions as driving point input impedance, or you can also write it as driving point output impedance, or driving point input admittance, and fourth, driving point output admittance. So these are some of the things that you can write. That means driving point input impedance, it is V1 by I1. Output impedance, V2 by I2. Input admittance, I1 by V1. Output admittance, I2 by V2. Now, let us learn what is transfer function. You can simply write this as ratio of variables at different ports. Like you can write I1 by V1 or I1 of S by V1 of S. Sorry, I1 of S by V2 of S. I2 of S by V1 of S. I1 of S by I2 of S. V1 of S by V2 of S. Or V2 of S by I1 of S. Or V1 of S by I2 of S. So these are several things that you can write. So you can classify them as forward transfer impedance, forward transfer admittance, reverse transfer admittance, reverse transfer impedance. You can also write it as current gain, forward current gain, reverse current gain, and voltage gain. So broadly, if you can say, you need not write all these things. Just you can say that current gain, what is that? I1 of S by I2 of S, or I2 of S by I1 of S. Second, voltage gain, V1 of S by V2 of S, or V2 of S by V1 of S. Third, transfer admittance. Fourth, transfer impedance. So admittance is I1 of S by V2 of S. This is V2 of S by I1 of S. So these are all the different transfer functions. So any transfer function, or you can say a driving point function, you can call it as f of s, which is n of s by d of s, numerator of s by denominator of s. For example, if you take one question like this, let's say the question is given, from that I'll write down this. find driving point input impedance. Driving point input impedance for the given network, and the network is given like this: inductor, a resistor, and an inductor, a capacitor, and a resistor. And the values are, this is 6, this is 1 by 2 is directly given, 5s, 3s, 5 ohms, I1 of s, V1 of s. If you write V1 of s, I1 of V1 of s is equal to I1 of s into, these three are in series, that is 5s plus 1 by 2s plus 6, and that is in parallel with 5, and again this total is in series with 3. So you can write V1 of s is equal to I1 of s into, if you just try to simplify this, what you get is, you get approximately 30s cubed plus 116s square plus 63s plus 5 by 10s square plus 22s plus 1. So in order to write driving point input impedance, it is V1 of s by I1 of s. So I can write this as directly V1 of s by I1 of s is equal to, this is the transfer function. And if you observe this, it has a numerator polynomial and a denominator polynomial. So as such, I told you f of s is equal to numerator polynomial by denominator polynomial. Numerator polynomial by denominator polynomial. Now if you make this numerator polynomial equal to 0 and find roots, they are called as zeros. And if you make this denominator polynomial equal to 0 and find roots, they are called as poles. They are called as poles. Now let us look at one question. Let us say you have one question like this example. Let's say t of s is equal to, given as s square plus 8s plus 16 by s into s plus 6 into s plus 9. Find poles and zeros. Now how do you do this? Now numerator equal to 0. You can write this as t of s is equal to n of s by d of s, where n of s is equal to s square plus 8s plus 16 is equal to 0, and d of s is equal to s into s plus 6 into s plus 9 equal to 0. So you can say s is equal to 0, minus 6, minus 9 are poles, and if you find s is equal to here, minus 4 comma plus 4 are zeros. Therefore poles 0 comma minus 6 comma minus 9 and zeros minus 4 comma minus 4. This is how you will determine poles and zeros of the given transfer function. Poles and zeros of the given transfer function. So we will discuss the rest part of this attenuators, image impedances of this unit 3 in the next session. So today we have discussed about two port networks and network functions. We'll solve some more questions on this network functions also. Thank you. So thank you all for once again for joining me today on this session on Unit 3 revision of network analysis and transmission lines. We have still image parameters, image impedance, and also characteristic impedance, which we can also discuss in the next transmission lines. So we'll try to take up one more session and try to complete that. So please do like this video, share this video, and subscribe to Unacademy. Use my code to get the maximum discount. Click on this bell icon to get more notification of my classes, and you can also join Telegram channel on upcoming videos. And please do subscribe to Unacademy and Unacademy Semester Exams, and let's crack GATE and ESE. Thank you all. Thank you once again for joining me today on this session on revision of network analysis and transmission lines, chapter 3 or unit 3. Thank you.